So this is the entry screen, and I said right at the beginning that it was meant to be something that was simple to operate, and it is. It's done with a click of a mouse. We've divided our country up into three, the south, the Midlands and the north, and you can see on this screen here that you can choose a number of different options, and this next screen is populated with my first choice, which is a building in the south of our country. The weather data happens to be London. It's a commercial building with single glazing, and we're putting a roller blind in those windows with a fabric type A. And if you hovered your mouse over this fabric type A, it would tell you that it's a highly reflective fabric. And that gives me an energy performance here, where you can see that potentially on that model building we have saved 9.4% of energy, and we've saved 15% of CO2. And the reason the two aren't the same is because air conditioning tends to use electricity. Electricity tends to produce more CO2 than gas, of course. So we can see in that sample building that we're saving around about €2.11 per metre squared. If I run the same analysis now for the centre of the country and the north of the country, it's exactly the same analysis, just moving the weather data. You can actually see that that actually affects the returns that you're getting. And it's that degree of flexibility that we've built in the model. And I would say that all the parameters and assumptions that have been made are there and published in the model for all to see as well. So that gives you the one element, which is obviously the amount of energy one can save, but the other thing is the whole issue of glare. And what we have produced here, using this probability model that I mentioned, is to take, in this instance, the southwest elevation of this sample office, and it actually shows that with no blinds, potentially 80% of the users would experience some form of visual discomfort, but with the blinds, virtually no one should receive visual discomfort. Now, the clever and alert of you here on a Thursday afternoon will notice that the lights are on when the blinds are down, and there doesn't seem to be any lights on when the blinds are up. That is merely a digital issue, not one that's actually in the model. But it is an important consideration as well, because internal lighting is a very significant consumer of energy in commercial buildings. So you can look at the energy saving, you can also look at how blinds perform in terms of glare reduction, and of course there may be different types of blinds there. But the other one I'd like to look at here now, specifically, just as an example, is a domestic building with a conservatory. So you can see that the little image in the middle here is different. It's a conservatory, it's southwest facing, same type of blind, a roller, and we get an energy reduction. And you can see it's relatively small, and it's relatively small because it doesn't save an enormous amount of energy in terms of heat rejection and internal shade. But of course an external shutter or a higher performing blind may well have an added benefit. But specifically at the moment, the way that we've used this in the UK is to look at this overheating of conservatories, where we can show that by applying correct blinds, a very expensive extension to your home that you've designed and built can actually be shaded more effectively. And this is an example here where we've actually run some specific modelling which shows without blinds that building, which is in the south of England, would reach a maximum temperature of 36 degrees. You'd only ever be able to sit in it for about 850, no, sorry, I beg your pardon, it exceeds 25 degrees C, and comfortable environment for 858 hours a year. You can see from the middle image there that if you apply internal shading, you can reduce that maximum temperature by about 29 degrees. And again, if you go the whole log and you do the internal and the external, the utopia for blind makers, you can reduce the temperature to about 26 degrees, and it only overheats for 300 hours. So it's that degree of flexibility that we've built into the model. If anyone would like to see the disk, we do have a sample of the shade specifier. It's currently run on CD, but you'll see in a minute that we're trying to make that available on a web-based platform. So the key targets for our for Shade Specifier, now we've launched the project in this time last year, is really the specifiers and architects, designers and engineers. That's our key target market now, to try and get that message across that solar shading can be reduce energy use, and if it reduces energy use, it reduces energy cost, and it also reduces CO2. And then moving ahead, we also want to develop the presentation for domestic homeowners. The benefits, well, Fabio went through most of these, but obviously energy saving is the key one, and that's what we've always been promoting. But if you can get in early enough, obviously you can reduce the cost, the capital cost of the building potentially, by using less air conditioning equipment and less heating equipment. It helps with that compliance, the regulations, the legislation. There is a very big increase in the green building rental income in the UK with the energy performance certificates. We touched on this, or I think Dick touched on this, of human capital. It's been calculated that 80% of the costs of running a commercial office are the people that sit at the desks in a building. So doesn't it make sense to make that more comfortable for them and to make them more productive? We obviously have the corporate social responsibility. We also have this exemplar, which of course the Energy Services Directive actually mandates government to be taking an exemplary role. And so it helps potentially with that as well. The whole process of getting data onto Shade Specifier is a relatively simple one. We are formatting a database, and most manufacturers of solar shading material would have had some form of testing already done. And most manufacturers do not need to do any retesting. That data merely needs to be formatted in the correct format for us to take the data and to validate that data. It will then go through, very much as it does in the glass industry, a peer review process of people within the industry reviewing the data. And then it is uploaded onto the database itself. I mentioned Wiz earlier on, and a lot of you will be familiar with Wiz. We actually use Wiz to generate some of the outputs that actually go into Shade Specifier itself. And these are the enlightened organisations to be early adopters, if you like, of Shade Specifier. We have a number of other organisations that are talking to us at the moment, but these companies have either submitted or will submit by the end of next month their data to go onto this database. And what will that database look like? Actually nothing like this, but it gives you an idea. We have a database that it will not simply be a giant spreadsheet or access database of information. It will actually provide the engineer or people looking at it with various statistics. And one of the key things is that it will be able to be used in a number of different forms, and I shall briefly come on to that, which is that we can produce the data from the database to the EN410 standard, but you can also choose to output the data to the ISO 9050 standard, which is the ASHRAE one. So if you're working in countries where you're working with architects, particularly from the US, then you can calculate all the data at the click of a button to that particular standard. So in conclusion, where do we go from here? We've done an awful lot in the last 18 months to get to where we are now, but there's an awful lot more to do. We obviously need to populate that shading materials database. If there are any people here today that are interested in that, then please speak to me or one of my colleagues later. We are trying to produce both the database and Shade Specifier in a web-based version, so it's open access, but also so that database changes become instantaneous. We'd love to run some additional simulations. We've run 500 simulations so far, about 50 gigabytes of data and analysis we've prepared. But it doesn't include brise-soleil, for example. It doesn't include certain glass types. It doesn't include a number of other things that we'd like to run. So we're working out how we can run these additional simulations as well. Winter heat retention, I think, is a key one, and it's one that we've perhaps overlooked. So we would definitely like to expand what we can do there. The ability to flex the key variables, and by there we mean particularly energy costs. The energy costs that are currently used in the model are 18 months old, and we know that when we speak to architects that specific buildings, people have negotiated either better energy costs than others. So to be able to input your kilowatt per hours and your cubic meter per gas costs in there will at least give you a more better feel for the energy savings. And obviously we need to start the promotion to the specification community to try and enlighten them as to what we have. So that concludes my presentation. I'd like to thank you very much indeed for your attention. I'd also like to thank the SSO for inviting us, and I hope that if you have any questions you can catch up with us after.